everyone, today I'll tell you about my project. It's about predicting electricity consumption. As we know that modern societies are becoming increasingly dependent on secure electricity supplies. Slovenia is on 11th position, first being Iceland. The energy is generated from the hydro, thermal, nuclear and solar plants. If the production is more than required, we need to store the electricity. Because of this, energy is lost in round-trip inefficiencies and results in additional cost. To overcome the storage and the environmental cost challenges, I'm working on this predicting electricity consumption project. The first step in this process was to identify the sources. Electricity energy use is closely related to what type of industry is it? Is it urban location? Or what is the climate and the geography? In this project, we focused on weather and holidays in Slovenia. So the next step was to merge these data from these sources into one data frame. After this, we did data pre-processing, which is basically cleaning and transforming the data for the next step, data analysis. Now I'll show you the data frame, which is already transformed and cleaned. So these are the columns received from the Slovene company. These are the derived date columns. These are the derived holiday columns. And this is weather information according to the regions, and there are few more columns which we have derived. The fourth step is exploratory data analysis. We performed a lot of analysis and visualized the data to understand it better. Here I'll tell you few of them. Using this figure, we tried to find the correlation between consumption and external weather factors and found that good correlation exists between consumption with temperature and radiation. This plot shows that the consumption is more at very low and at very high temperatures, which proves the fact that more electricity is required for heating and cooling purpose. In the next analysis, we see how the consumption varies in a weekday in every 15 minutes. Here in red, we see the average consumption. Green curve shows mean plus standard deviation, and the blue curve shows mean minus standard deviation. We observe that consumption is more during weekdays and very less on weekends. Next, we perform unsupervised learning. Clustering is a machine learning technique that involves the grouping of similar data points, while data points in different groups should have highly dissimilar properties. We have obtained these highlighted groups of clusters for one consumer using statistical methods. Here, the dendrogram visualizes daily consumption, which is divided into 3 different groups of days. This is obtained using hierarchical clustering with custom distance metrics. Using this method, we reduced variance in the data by 84%. Another such method is k-means clustering. In this graph, these components explain 94% of the point variability. We use all this cluster information to perform the consumption predictions. So, this leads to our next step, which is supervised learning. Using this cluster information, the relation between consumption with various factors like day of the week and the holidays is found, and using this we approach towards a goal of the project, data prediction, which is shown by this graph. The black curve is the actual consumption and orange curve is the prediction. This prediction error is equal to the difference in area between the two curves. This is shown by the shaded area in this graph. The smaller the area, the better is the prediction. The usage of electricity energy resembles a trapezium function. In this figure, the trapezium is the prediction and the grey shaded area is the error. As we see that grey area in this figure is larger than our prediction model, that means our model is better. So all this cluster analysis we did resulted into very good predictions. After these statistics and data mining techniques, we adapted the data to NoSQL and Hadoop framework. We used our Mongolite package to work with NoSQL MongoDB database. Here, we perform data retrieval, manipulation, and analysis using the data stored in MongoDB. We have adopted some of the algorithms to our Hadoop, which we have made available on FutureLearn course named Managing Big Data with R and Hadoop by Praise and University of Ljubljana. We have made the data available for you to practice in this course. The example explains how to do data formatting, aggregating, calculating mean standard deviation, and then plotting the results. This is the best course on how to manage large amounts of data using Hadoop MapReduce in our environment. So I recommend you to take this course and provide us with your feedback. Thank you for watching.